So in this video we are going to discuss about the diffraction of X-rays, okay, through a crystal. So the diffraction of X-rays through the crystal, because why we are doing from the crystal, because if you talk about the X-rays, they are like, you can say that we cannot do the diffraction by the X-rays by the diffraction. We are doing the diffraction by the crystal. Why? Let's see. First of all, if you talk about the Bragg's law, what is Bragg's law, that we'll be discussing in today's video. But before that, if we talk about the X-rays, X-rays are what? X-rays are electromagnetic wave. What are electromagnetic wave? Electromagnetic wave are basically the short wavelength. The wavelength is very short. That's why we cannot the diffraction is like we cannot, you can say that, find out the diffraction of X-rays. That's why we are finding the diffraction from the crystal. Okay, we cannot find out the diffraction of X-rays. We are finding the diffraction of X-rays by the crystal. Okay, as well as if we talk about the wavelength, so their wavelength is like 10 multiplied by 10 is power minus 10 meters. It means it's very short. Okay, so if we talk about the diffraction of X-rays, it's basically not possible by the Young double slit. As you guys all know, we were having the Young double slit experiment of the diffraction. So we are not, the X-rays cannot be diffract by the, is not possible by the Young double slit. That's why we are doing the diffraction of X-rays by the crystal. Let's see how. Okay, so in X-rays, the diffraction is basically not valid by the diffraction grating 2. Okay, we are having that one another experiment to find out the diffraction. We cannot find out the diffraction of the X-rays by the diffraction grating 2, because of X-rays is basically very short and their spacing is very more. For example, we are having a ray is coming, and if we talk about this, so their spacing will be equal to the wavelength that can be passed and the diffraction can be occur, but their spacing is very too much. Okay, and wavelength is very short, so the diffraction cannot be occur. So that's why we are doing the diffraction by the crystal. Why crystal? Let's see. First of all, the how crystal, first of all, the rock salt is used. Okay, rock salt is used. We are doing a diffraction of the X-rays by the crystal, so the rock salt is used, as well as the atom are uniformly arranged. Okay, like equally spaced, uniformly arranged. Like for example, this is a one rock atom. We are taking this rock salt piece of atom. Okay, so they are uniformly arranged. So that's why the diffraction is possible by the X-rays, and their spacing is very equal, you can see that. So that's why it is possible. Okay, so for example, we are having the, you can see that the spacing are basically same. That's why we are going to diffraction of the X-rays through the crystal. So for example, the ray is coming from here and it is strike with this atom and it got reflect. One more ray is coming from here and it basically strike from here and it basically go back. So here you can see that the angle is there. Okay, we can, here this is the D is what the distance of this, and that is equal to what? That is equal to the 10 is power 10 meter. Okay, which means the equal wavelength. So that's why they are having the equal wavelength and spacing too. So that is why it is possible to do with the crystal. So here you can see that we can write here that the part difference, if we talk about, okay, the part difference, we are having two part difference, 1 and 2 part difference. We can write it S1 and S2 part difference. Okay, and here we are having the angle. Okay, so we are having what? We are having the 4 beam of light, 1 2 3 4, and 2, you can see the part difference. So let me I'm making this same structure here of this angle so you can easily understand. Okay, so here we are having the S1 and S2. Okay, so here we are having the angle. Okay, so we can write here that angle, from angle their side can be the perpendicular, and it can be the hypotenuse, and it can be the base. This is the this one angle S1. This is S2, which means the perpendicular, hypotenuse because of the d distance. Okay, and the base, we are having this base, hypotenuse as a d because of this d here. Okay, so we can write here that sine theta is equal to the perpendicular upon hypotenuse. We are using this formula, and sine theta is equal to perpendicular upon hypotenuse. Okay, so as you guys all know, perpendicular is equal to what? The, we can write here the S1 upon d, and here S2 upon d. So it can be the S1 is equal to d sine theta. Okay, and we are having what? Sine theta, sine theta. Okay, S1 is equal to d sine theta, and here S2 is equal to d sine theta. So if we talk, this is a both part difference we are having. Okay, so we want the total part difference, so we can write it S is equal to S1 plus S2. Okay, so we are adding these both, like S is equal to d sine theta plus d sine theta. Okay, and the answer will be the S is equal to 2d sine theta. This is the equation number 1. Okay, now if we talk about the condition of the constructive interference, as you guys all know, the S is equal to m lambda. Okay, so this is the equation number 2. So if you're comparing both equation, equation number first and second, so we will be having the m lambda, which is equal to the S and equal to the 2d sine theta. So this is the Bragg's law. This is the Bragg's law. So m is what? M is the order of fringes. This will be the lambda used to calculate the variation in the X-rays. Okay, this is the formula to find out the calculation of the X-rays or the wavelength of the X-rays. D is what? D is the spacing of the atom. So for example, I'm giving a question that for example, that I'm having the lambda, we have to find the wavelength of the X-ray, and the D we are having that is 0.05, or M I'm taking the fringes as 50, and angle I'm having 3. So we can write this formula and we can find out easily the wavelength of. Okay, so 50 lambda is equal to 0.05 and sine 3. Sine 3 is equal to 0.05. Okay, 0.05 to lambda is equal to, okay, 50, and here will be the lambda is equal to the 1 multiplied by 10 to the power minus 4. So we are having the wavelength of the you can say that about this data. Okay, so we can easily find out the data. Okay, so